I'd like to add just a quick couple of comments about global change, and that is that global change also includes rising sea levels, any alteration to biogeochemical cycles, decreased biodiversity, and emerging infectious diseases. Okay, so now we are going to move on to the natural greenhouse effect. So as you can see, we'll have 5 slides on this. First, we'll have some information provided in writing, and then we'll look at a diagram. So our planet is naturally warm because of solar radiation. Solar radiation means energy coming from the sun, and it's made up of ultraviolet and visible light. About 1/3 of the solar radiation that reaches Earth is reflected back out into space. So cloud cover, ice, snow, etc. would reflect some of that energy back into space. A portion, called the ultraviolet or UV portion, is absorbed by the ozone layer. Remember, the ozone layer is at the very bottom of the stratosphere, just above the troposphere. The troposphere is from 0 to 10 miles above Earth, and it's where the vast majority of gases are and where most of our weather occurs. So the rest of the energy that is not reflected back or absorbed by the UV portion is absorbed by clouds and by the Earth's surface. And when these molecules absorb this energy, they then re-emit it as a form of radiation known as infrared radiation. So if you had a spectrum in front of you, you would see ultraviolet down here on the left, visible light comes next, and then infrared radiation would be on the right. So it changes the wavelength of the radiation, but it is nonetheless a warming radiation. Okay, the Earth has natural greenhouse gases. These are gases in the atmosphere, in the troposphere specifically, that hold some of the heat and radiate it back to the surface. If they didn't, the Earth would be frozen and we wouldn't have life on Earth as we know it. Okay, here's a diagram of the natural greenhouse effect. So here's the incoming solar radiation, some of it being reflected back by atmosphere and clouds, some being reflected back by reflective surfaces on Earth, such as ice cover or snow. And then here we have the remaining solar radiation being absorbed by clouds and the surface of the planet. Both become warmer and then emit a different wavelength of radiation called infrared radiation. Infrared radiation is the type of radiation you can feel and almost visualize in the summer on a paved parking lot, for example, and there's like a shimmer coming back from it. So the dark surfaces tend to hold that heat more, absorb that heat more, and re-emit it back in a different energy form, which is the infrared radiation. But this also occurs in the greenhouse gases in the atmosphere. So when the greenhouse gases then absorb the infrared radiation and then they warm and emit it back, much of it going back toward Earth. Some, of course, will go in the other direction. But here's the main point. The greater the concentration of greenhouse gases, the more infrared radiation is absorbed and then emitted back toward Earth. One word of caution that I would add about this diagram is that it makes it look like there's almost a glass ceiling here, as though you would have in a real greenhouse. And it's not that way. So even though it's called the greenhouse effect, there's not a barrier here, a sharp divide that's glass that then absorbs and maintains and traps the heat. It's the gases in here that are doing so. Okay, so what are the greenhouse gases? Water vapor, carbon dioxide, methane, nitrous oxide, ozone, and all of those just shown in green are gases that can occur naturally and do occur naturally in the atmosphere, in the troposphere. And this one in purple, CFCs, chlorofluorocarbons, are only man-made. Now, here's an important point. Most of the atmosphere, 99% of it, is made of just nitrogen in the form of the N2 molecule and oxygen in the form of O2 molecule. That's 99% of the atmosphere does not contain greenhouse gases. So therefore, you can see that these are going to be present in very small quantities, but those small quantities can still have large effects. And even if we exclude the CFCs here and just look at this 1% making up all of these gases and more, you can see that that small 1% historically kept the Earth warm. So changes in the quantity of any of those can have an important effect. So this is a table from your textbook, and it lists the major greenhouse gases and what their concentration in 2010 was. And then we'll look at two other factors, global warming potential and duration in the atmosphere. So you can see, for example, that carbon dioxide in 2010 was 390 parts per million. So by the way, here we are in 2020, not even finished 2020, and we are up to 413 parts per million concentration of CO2. Methane is present in much smaller quantities, 1.8 parts per million, and then nitrous oxides and chlorofluorocarbons are also in small quantities. But then we have to consider their global warming potential. That is, how much do these particular molecules absorb and re-emit infrared radiation? And if we use carbon dioxide as a baseline of 1 and compare these other greenhouse gases to carbon dioxide, you can see that methane is about 25 times more potent as a warming gas than carbon dioxide. So even though it's present in smaller quantities, it's more powerful, and these quantities as well have also been increasing. Nitrous oxide, 300 times more global warming potential than carbon dioxide, and CFCs, crazy 1,600 to 13,000 times. So that's a consideration. The next thing to consider is how long these gases are present in the atmosphere. Water vapor is obviously very variable, but typically 9 days if you take a huge average all over. Carbon dioxide is also somewhat variable. It may be around for years to hundreds of years. Methane, about 12 years duration in the atmosphere, so relatively long period. So if we're adding and adding and adding, it's not like an equal amount is being removed. Nitrous oxide, 114 years, and CFCs maybe anywhere up to 500 years. So greenhouse gases, as we said, have been present on Earth and resulted in natural warming. So we'll look first at the natural sources, and then we'll look at the anthropogenic sources. Some of the natural sources include volcanic eruptions, which mainly release carbon dioxide, decomposition, where plants die and are broken down by bacteria anaerobically, producing methane. Denitrification, which is the process, the part of the nitrogen cycle where nitrogen from the atmosphere, N2, which isn't usable by plants, is converted via bacteria and other organisms into a form that is usable, and that process is called denitrification. And last, the water cycle, of course, cycles the water through the atmosphere. Then when you add in anthropogenic sources, we have the burning of fossil fuels. So when we combust things such as gasoline and coal and natural gas, we have a lot of CO2 released. Agricultural practices, combination of things released. There's a lot of nitrous oxide released due to some of the practices. There's also methane released by livestock, and there's CO2 released by burning of fossil fuels to power farming equipment. Deforestation results in a release or an extra amount of CO2 in the atmosphere. So how does that work? So when you deforest an area, you no longer have as many trees. And those trees were absorbing CO2 from the atmosphere. So they were removing CO2 from the atmosphere. And once deforestation has taken place, they're no longer there and the CO2 remains even longer. Landfills we've talked about before, but when we bury waste in landfills, it is decomposed again by anaerobic bacteria, producing CO2 and methane. And last, industrial production. That's primarily where the CFCs came from, but industrial processes produce a number of greenhouse gases. So next, let's look at the sources. Okay, so this is not a slide I want you to memorize, but just to put some things in perspective here. So we have methane here at the top. Again, livestock digestion, landfills. So in the previous slide, we were looking at what the activity was and then what it produced. Here we're looking at what gases produced and by what activity. So we're going in the flip direction. So we also have natural gas and petroleum, including leakage from extraction processes, coal mining, manure management. So remember, that's when like the hogs are just, the manure is just put into a manure lagoon, and as it decomposes again anaerobically, produces methane. Second one here is nitrous oxide. You can see the vast percentage, about 70%, comes from agricultural soils. And carbon dioxide, this graph, let me point this out, it's a little tricky to see. We do have fossil fuels not used for energy and some iron and steel production and things like that. Those are all less than 2.5%. But fossil fuels used for energy actually releases about 94% of the carbon dioxide that is released by humans into the atmosphere. So if this bar didn't have a gap in it, that 94% would stretch, across the room from here. Okay, this is another good spot to stop.